Hi, I'm Josh Hooks. I'm a solution architect at Software AG, and I'm here to show you an example using Cumulocity IoT of how we can take our digital twin manager concept and augment it using streaming analytics to aggregate information from a number of devices into an asset where you would want to create intelligent dashboards and see things in a single place. And to do that, we're going to start with our Cumulocity tenant that we have here, and specifically in our digital twin manager application. And within here, we have a digital twin library setup that shows the structure of how I'd pull in a new asset. In this case, pulling in a new factory into Cumulocity IoT. And within that factory, we have lines and areas. And within that line, we have conveyor belts, OPC UA servers, robots, and CNC machines. You can set this up really however you want and inherit different numbers of the conveyor belts or different number of devices and assets within each of these lines. And in this case, I'm just going to focus on the conveyor belts. So in this case, I might have 5 conveyor belts within a single line, but I want to see the average rotational speed of those conveyor belts, not on the conveyor belt level, but on the line level. That way, on that factory line, I can create a dashboard that shows me all the information I need in one place. So to do that, I'm going to jump over to our streaming analytics application and specifically the EPL apps portion of it. EPL stands for Event Processing Language. It's the programming language behind our analytics capabilities. And I'm seeing a number of models here for different kinds of use cases, but I'm going to focus on this aggregate analytics model. So when I click on this, it'll take me directly into the code of our EPL apps. And I won't focus right now on exactly what's in this code. Instead, we'll look over at the samples. The samples are how I would really start any model that I'm building in EPL apps. So thinking of the use case of looking for data or looking for measurements, rotation speed to be specific, on these conveyor belts and aggregating it by recreating and averaging that measurement and putting it on the line level. I'm just going to key off the query for measurements part of that and look for a sample that says query for measurements. So this would be essentially how I would start building this out from scratch when I think about these kind of use cases. So I won't look at the sample too much right now. It does a lot of the same stuff as the finished example that I'm going to walk through right now. And I'm going to ignore the metadata, things like, pulling in different libraries. A lot of this is pretty standard, and focus on a lot of what makes EPL apps special. And in this case, we're going to start with the monitor. So we set up a monitor first called Aggregate Analytics. Monitor is essentially like a class in another programming language like Java, where it just holds a number of variables like what you see here, or functions that we call actions, and then is able to replicate those. So in this case, we set up our variables, and then we're going to use the onload action. This is really important as it makes it so that when you activate the model, it automatically runs this onload function and everything that's in it. So in this case, we're going to use the monitor that we have set up and then set up a subscription to the manage object channel. This is essentially just saying I'm going to subscribe to something within our manage objects. And manage objects are, best way to think about them in Cumulocity is they're part of the database that holds the devices and different inventory information about the devices, assets, and everything that's happening in Cumulocity. So to do that, I want to first query for the information that I want to start with. And to do that, we'll create a find manage object, object, and then look for a certain group name. So here I'm doing a query that's part of our APIs that lets me look for a name equal to the group name. And the group name in this case is line 1. There's a bunch of different ways you can kind of query for this. In this case, I'm just targeting a specific line to be as simple as possible. And then from there, I'm going to use that same subscription channel to send off that find manage object, and then have the find manage object response be the callback for where that's sent. So instead of a typical programming way of calling an action and having it return something immediately, this is more event triggered. So I'm sending off an event that's saying I want to find this, and then I'm using the find manage object response as the callback to get that information whenever it's ready. So we do the query, it's then ready, and I look at all the responses that have come in, individually to see how I want to take action on them. And in this case, I'm looking for the children of this group. So within a group or asset structure, you can have a number of devices in there that are considered the child of the parent. And these children are going to be how I associate which devices I want to actually take action on. And so within here, I'm saying if there are any children, if it's greater than 0, let's do some group statistics on those children themselves. So on the conveyor belts. Conveyor belts will be the children of this line device. And so if I go down to what group statistics does, this is an action. So this is like a function or a method that just does some kind of action in the back end. And in this case, I'm going to look for the devices, which are the children within this group, and then start looking at the measurements that are within each of these devices. So I am looking for that rotation speed. And then if I scroll back up to where I created these variables, this is how I know what kind of measurement I'm looking for. I'm looking for a speed value that is actually rotation and a unit of RPM. So if I scroll back down to group statistics and I'm looking for on all measurements of that type, I want to route that information to this group measurement event. This is probably the most complicated part because a lot happens in the back end without you having to really do anything. When you route something to an event, you're going to route it in a way that you're looking for all of the information within a certain window. So from that group measurement, within the past 60 seconds, you're going to group that information by the group ID. So essentially just saying everything within line 1 from the measurements that I got, let's average it out. A lot happens within this small piece of code that says if I'm going to average the group measurement values of the measurement, so I'm averaging the sensor values that are telling me the rotation speed for each of these conveyor belts and storing that as this average measurement. So what I've taken here is within the past 60 seconds for every conveyor belt, I'm getting the average value of what that rotation speed is. And then I'm going to take that information, which is really where I want to get to. I want that average for the past 60 seconds and create that measurement on the group level or the asset level for the line. So then I can build that dashboard in that line level. And then that triggers this another action called create measurement, which is probably the easiest thing to think about. This is the same in really all of our examples. It's a way to create a measurement. You structure it by type, give the time, and then create what the measurement looks like, standard across any kind of use case. And this will create that measurement on that group level or that asset level. So then I can go to that line, create a dashboard that shows me that aggregated information instead of having to go individually to each conveyor belt to see the information of that average value. So hope you enjoyed this use case. Just a quick example of how you can use EPL apps within Cumulocity to further augment the capabilities that we have in Digital Twin Manager.